This is the lesson for for the study guide for quiz 12 for algebra. So let's take a look at the first problem here, and they're asking us to solve for y. So we solve for y whenever we want to come up with the slope-intercept form, because it gives us our y-intercept and our slope just by looking at the equation. So that's the reason why we'd want to do this. Now typically when we do that, I'd put the x term first, and so that's what I'm going to do here. I have 3y equals negative 2x plus 9. If you wrote 9 minus 2x, it's the same thing. From there, I'm going to divide by 3. Again, you're dividing every term by 3. So I'm left with y equals negative 2/3 x plus 3. So that is the answer for the first one. And the next one, it says solve for h. I want to get this h by itself. So since 1/2 is being multiplied by the sum and by h, I can multiply the entire side, right-hand side, by 2 over 1. That will cancel out that fraction. What I do to one side, I always do the same thing to the other side. So that way I'm left with a 2a equals that sum of f plus g multiplied by h. So from that point, I'm ready to divide by f plus g because that's what I need to get rid of to get h by itself. And I'm left with the answer of h by itself. So you can see how h is now by itself, with the product of 2 and a on top. Down below the fraction, I've got that sum of f plus g. So the next one, I need to solve for f first. And so my first step is to get rid of this fraction. So I'm going to do that by multiplying by the reciprocal. That's going to cancel out the 9's and the 5's. And then I do the same thing to the other side. So I'm left with 9/5 c equals f minus 32. So from that point, all I have to do is add 32 to both sides, and I get the answer. 9/5 c plus 32 equals f. So that's one of the parts. The next part is to tell which is greater, 350 degrees or 120 degrees Celsius. So I'm going to take that 120 and put it in for c here. So I'm left with 9/5 times by 120 plus 32. Equals the degrees Fahrenheit. So multiplying 120 by 9/5 is going to leave me with 216. And so I can rewrite this as 216 plus 32. And so from that point, I can go ahead and add those two numbers together, and that's going to leave me with 248. So 248 degrees Fahrenheit, which is less than 350 degrees Fahrenheit. So I'll say that 350 degrees Fahrenheit is greater than 120 degrees Celsius. That would be my solution. Now let's move on to the next set of 3 problems, and here we are graphing this function. Now this is an absolute value function, so anytime we've got absolute value of x equals y, it's going to be a right side up v, where the v is going at a 45-degree angle with respect to a horizontal line. So what happens is this vertex moves space, or moves into a different location when we're trying to graph this. And so here I end up going down 3 spaces, because if I put 0 in for x, that's going to cancel out the absolute value sign, so I'm just left with y equals negative 3. So the vertex is going to end up being 0, negative 3. So that's where I'm going to end up starting. And then from there, it just forms that angle, that 45-degree angle. It's 45 with respect to a horizontal line going out in this direction. So it does the same thing here. So this is called a piecewise graph, because the values of y, or the domains, are changing with respect to the range values at a certain point at this vertex. Here they're going down at a constant rate, but then they hit this vertex and they change. They change to going up at a constant rate. So we're going to have that same v, but in a different location for this one. So this one, whenever the number's inside the absolute value bars, the vertex is going to be along the x-axis, where if it's outside, it's going to be along the y-axis. So we can find out where by figuring out what makes 0. And so you see, if I put negative 2 in for this x, add 2, I get 0. Absolute value of y is 0, it would be 0. So I go over 2 spaces to the left, put the dot right there, and that's where it's going to start to change directions. And so it's going to end up going up to the right on the right-hand side, and then up to the left on the left-hand side. So that's what our graph ends up looking like. So on this next one, it says a jar contains only nickels and quarters. So we want to find out how many quarters. So let's go ahead and define some variables. Let's say n equals the number of nickels, and we'll say maybe q equals the number of quarters. And so from this point, I'm going to start with a quantity equation. N plus q equals 69, because it says there's a total of 69 coins. Of nickels and quarters make 69. Then it gives us a value of a total of $10.05. So the value of the nickels is 5 cents. So 5/100ths of a dollar times the number of nickels plus 25/100ths of a dollar times the number of quarters is going to give us $10.05. So we want to solve for quarters. So let's cancel out the nickels. Let's multiply that top equation by negative 0.05. And so if I do that, I get negative 0.05n minus 0.25 q equals, and I get $3.45, but it's negative. And so when I add this together, though, I'll cancel out the nickels. I'm left with 0.2. Oops, this needs to be 0.05. So let's change that real quick. Right here. So when I multiply 0.05 times q, that's 0.05q. And that's going to leave us with 0.2q equals $6.60. So when I go ahead and divide by 0.2, it's going to move the decimal over one space here as well, and I'm left with 33. So q equals 33 quarters is what I end up saying there. So moving on to the next set of 3 problems, here it says that, there it is. So Bert and Leslie drove a total of 655 miles in 13.2 hours. So those are both totals. And so it says Bert drove the first part of the trip, averaged 55 miles an hour. Leslie drove the remainder and averaged 45 miles an hour. Okay, so here's what we want to do. Find the length of time Bert drove. So let's come up with some variables. Let's say b equals the number of hours Bert drove, and we'll go with L for Leslie. L equals the number of hours Leslie drove. Alright, so now we're going to come up with a quantity equation. B plus L is 13.2. Remember, B stands for number of hours. L does as well. So those two add together to make 13.2 hours. Now we've got a total number of miles. So if we take the number of hours, multiply it by their average speed, it's going to give us the total miles Bert drove. Same thing with Leslie. 45 miles an hour times the number of hours she drove gives us her distance, equals 655. So we want to solve for Bert's length. So let's cancel out Leslie. So negative 45 is what we need to multiply each of these terms by. So negative 45b minus 45l equals, and that gives us negative 594. So when I add this together, I end up getting 10b equals, and this gives me 61. So when I do that division, it moves the decimal over one space to the left, so b equals 61 or 6.1 hours, which is 6 hours and 6 minutes if you change it to that. So here it says a plane flies 300 miles with a tailwind. So that's total distance with a tailwind. So tailwind means that the wind pushes plane. So it's going to make it go faster. So that's going in 1 hour, and then it takes the same plane 2 hours to fly 300 miles against the wind. Alright, so same distance, but a little bit longer because it's working against us, the wind is. So let's assign some variables. We'll say p equals the number of, let's go with number of miles per hour. So let's change that. Let me rewrite that as plane speed. Plane's speed. And we'll go with w equals wind speed. Alright, so now we'll go ahead and write our equation. So our general form for a distance, rate, and time problem is distance equals rate times time. So the distance, 300 miles. Rate, well, it's the plane speed plus the wind speed because it's pushing us. The wind is pushing us in 1 hour. And against the wind, 300 miles, P minus W, because we're working against the wind, it took 2 hours. So a good way to solve this is to go ahead and use some division. Get the P and W by itself. So I'm going to go ahead and divide by 1 on that top equation, divide by 2 on the bottom. So now I've got two new equations. 300 equals P plus W. And then on the bottom, 150 equals P minus W. So when I add that together, I get 2P equals 450. So when I divide by 2, I get my answer. So that makes half of 400 is 200, half of 50 is 25. So 225 miles per hour equals the plane's speed. Plane speed. And so when it says plane speed in still air, that means just the plane speed without the wind. So moving on to the next problem, it says how many gallons of a 50% solution. Okay, so we don't know. That's what we want to find. So let's go ahead and assign that a variable. X equals the number of gallons of a 50% solution. So it must be mixed with 30 gallons of a 19%. Okay, they gave us that amount. We already know that's 30 gallons. But we don't know, to obtain a solution that is 19%, we don't know how many gallons of the 40% we have. So let's assign that variable. So number of gallons of a 40% solution. So now we'll go ahead and write the equation. X plus y equals, oops, not x plus y this time. Let's change that. X plus 30 equals y. How did I get that? Well, it says that we're going to mix a number of gallons of the 50% solution with 30 gallons to obtain a 40% solution. So we're going to start with our 30 gallons and start adding some X, some 50% alcohol solution, and then eventually get to a 40% solution. So that's our first equation. Next equation is that's a quantity. Let's go with a value. So it's the value of the X, the number of gallons of 50% solution. So it's 0.5X plus 30 times 0.19, because that's a 19% solution, equals, and then we want 0.4 times by y. So this is a great one for substitution. So if I take this x plus 30 and put it in place of y, this is what I get. So let's go ahead and rewrite the equation. 0.5x plus 30 times 19 gives me 5.7, or at least 30 times 0.19, and then 0.4 multiplied by x plus 30. So I'll go ahead and distribute. So my next step is this. 0.5x plus 5.7 equals 0.4x plus 12. So 4 times 30 is 120. Move the decimal back one space. That's where I'm getting 12. And so I'll go ahead and do some opposite operations. So I'll subtract the 0.4x, and I'll subtract the 5.7. And now my next step reads this. 0.1x equals, and then I end up getting a, let's see, 6.3. And so when I divide by 0.1, it's going to move that decimal over one space. Same thing here. And the division gets real easy then. 1 into 63 goes 63 times. So 63 gallons. Gallons of the 50% solution is what we end up needing. So those are the types of problems you're going to see on today's or this week's test. Good luck.